Okay, it's asking a question, does this sign of this crazy looking number have a limiting value? The hope here is that you start to realize that this is the, appears to be pi without the decimal digit, okay? So the way I would kind of approach this problem is one is to maybe point out the obvious, that there's going to be a sequence of terms here, and the sine 3, sine 31, sine 314, with the understanding that the arguments over here, for example, the first argument is 3, the second argument, and when I say first argument, I call it A naught, A1 is 31, A2 is 314, with the understanding that AN appears to be the floor of some, I'd say multiple, the multiples are powers of 10, by the way, of magnitude. So pi, all right? So again, A0 would be, 10 to the 0, which is 1. So the floor of pi, in this section we discussed the floor, would just be 3. A1 would be 10 pi. And what would that give you? That would give you 31, right? Again, we're not asking you to memorize the digits of pi, by the way. It's okay to use a calculator on that, and so forth and so on. So really what we're asking you to do is kind of a crazy looking limit, by the way, the limit as n goes to infinity, and the sine of the floor function 10 to the n pi. Now, granted, again, the emphasis here is n some integer, like 1, 2, 3, 4, right? I get some intuition over here. So if I were just looking at this over here, sine, and I just had this over here without the floor on it, I'm pretty comfortable that my reasoning over here is that, certainly the first number, if I looked at the sine, like I took n to be 0, I would get the sine of pi, which is 0. And then I would just get even multiples there on out, and they'd all be 0. So I'm comfortable in saying that this would be 0 over here. But the floor function really throws a problem into it. But I mean, intuitively, I'd say, oh, gee whiz, it really can't affect it that much. So I would say, oh, this must be 0, all right? So I'm going to put a question mark above this, and I wonder, really, is that true? All right, so my intuition says it's 0, but I could be wrong. All right, let's be a little more precise, by the way. So what I did over here is I looked at it, and again, we're looking at this over here, and I just wrote down something like this over here. I'll put down what I mean by that. 10 to the n pi plus the floor, 10 to the n pi minus 10 to the n pi. I hope it can be agreed upon that there's simply just the floor of 10 to the n pi. Nothing's changed over there, all right? So the arguments are the same, all right, which is good. All right, next thing I'm going to do is I split into basically like the sine a plus b. And I get my eraser out and emphasize that the sine of a, let's see, yeah, the sine of a minus b, let's write this down. The sine of a minus b equals sine a cosine b minus sine b cosine of a. All right, so let me outline what we're doing over here. Let me get my eraser out, and we're taking this a and b problem, right? So give me one moment, and this is going to be my a, and this is going to be my b over here. All right, so what do I write down? Basically I'm just using this formula over here. So sine of 10n times pi, then I got the cosine of this over here, minus the sine of that 10n pi minus the floor, and this over here. All right, so I'm back to something that's familiar to me, and they're pretty comfortable in saying that, again, this is going towards 0. And this one over here, a little more interesting. I want to point out, if I took n to be 0, what would you get? You get the cosine of pi, which would be minus 1. But if I take any n greater than or equal to 0, I would get an even multiple of pi. and that would be, the cosine of 10n. Again, with the understand that n is, I shouldn't say equal to 0. Sorry about that. Let me write that down again. Whoops, I lost that, didn't I? Let me start again. So cosine, again, if n is 0, I would get pi, and that would be minus 1. Now, if the n is greater than or equal to 1, the cosine of 10n pi, that would be an even multiple of pi. I'm sorry, cosine of pi is minus 1. I'm really screwing up there. This would be always 1. All right? So this limit really boils down to something pretty simple. And what does it boil down to? Basically just this term over here. All right, that's what it boils down to. All right, so our original limit, which is this guy over here, is actually the same as this limit over here. All right? Now this is where, I'm going to say that certainly we need a little more precision on what we're saying over here, though. But you would get a sequence of numbers. And the sequence of numbers you'd get over here for the argument, I'm talking about the argument now, you'd get this sequence over here. Again, I'm just approximating the sequence. They go on forever, by the way. But one thing I want to point out about pi is an irrational number. So I'm going to say this listing of numbers over here is bouncing around, and the sign's going to bounce around. It's going to bounce around forever. It's never going towards any one particular number. All right? So I'm going to say over here that just kind of intuitively, I'm going to say now that I'm now convinced this does not exist. All right? Remember before that FLIR function was kind of bothering me, and now I'm kind of writing a sequence down. It's not bothering me so much anymore. But I want to point out this is not so precise. All right? So what I wanted to do is, I strongly suggest to watch the link video. It's how a university quality lecturer would present the problem, by the way. And therein lies a big difference, by the way. I want to point out a lot of times what's happening is you're getting an argument that's not terribly precise, by the way. So I would definitely try to watch the video. This video over here, it's linked for you. Just click on it. You'll take to the linked video, and you'll see a university, what I consider a university quality lecturer, present this same exact problem. All right. Now, where it diverges right now is in this argument over here. My argument is less precise. His argument is much more precise. Does it lead to the same conclusion? It does. It doesn't exist. You may want to listen to both. Thank you.